Hello, and welcome to AWS Review, a weekly look at what's happening at AWS and how it may change how you do business. I am your host, Michael Krause. I am the Chief Technology Officer at Charter Solutions, where we help organizations change and innovate quickly by accelerating their acquisition and use of data.
And I'm your co-host, John Affolter. I'm a lead technical architect on the AWS specialist team at Salesforce, where I work with potential customers and help them envision the possibilities that Salesforce and AWS enable together.
Excellent. Well, welcome to another session, John.
Yeah.
And we've kind of talked about weather a lot on these things, and I have to give it another shot here because summer has officially fully arrived in Minnesota, and you know it has because we are now in multi-day excessive heat warnings.
Yeah, just like I said last week, be careful what you wish for, and of course that definitely came through. But yeah, the weather is definitely providing some good content for us, per usual within Minnesota. So yeah, and then this weekend, I know I was telling you earlier before we started, but yeah, my brother Jacob, my little brother Jacob, and Allison got married last weekend. It was a really great ceremony. It was at Hope Glen Farm. So a little shout out to the venue. If you ever are looking for an outdoor venue or a farm type venue, it was pretty amazing. So,
And that was on Saturday, correct? So it was actually
yep.
a reasonable weather day. It was
Yeah,
before the excessive heat.
Yeah, missed the 95 degree. It was still, we were still sweating up there in the sun during the ceremony, but it went pretty quickly, and it wasn't too bad. Just a couple of wipes of the head, and we were good. But if it would have been Sunday, I don't even want to think about it. Actually.
Heat exhaustion, lots of heat exhaustion.
Awesome. So before we move into the topic of the day, we usually do an update on AWS. And I think this might be a bigger update than any of them, that there were no tech announcements last week in AWS.
Yeah, they had a number of blog posts, but they're all kind of marketing posts and third party, no actual announcements of updates or new technologies or anything like that over the last week. So that's the first time for us so far. I don't know if it's the first time for AWS, but since we've started this show, this is the first time we've run into this.
Yeah, so that's it. Again, that's pretty crazy in itself. So they must be gearing up for something. Some people
out here. Well, it's a few more months, and we're going to have reams and reams of announcements, both the pre-reInvent conference announcements, the during reInvent conference announcements, and then the post-reInvent conference announcements.
Yeah, we might have to have a separate show just for all the announcements. I think it'll be pretty. I'm looking forward to this year's one. So
a lot of fun. Well, since we have no announcements, we may as well dive right into our content for the day, which is taking a look at data federation capabilities in AWS. And we've talked a lot recently about the convergence of analytics and applications and data on AWS. We've talked about curation of data and transformation of data. And, we've talked about the modern data architecture on AWS. So diving into some of that a little bit, one of the enablers around the modern data architecture is the idea of data federation.
Yeah, and, I always like to start off with a good question for you, Michael, and I guess it's a real easy one. What defines a federated query?
I'm probably sure you go out to Wikipedia or other sites and get a really nice, clean definition. But what we're going to use as our working definition today for our content is a federated query is a query that can be executed within one query engine or database platform and have it draw results from other external data platforms as well to generate the results of the total query. So you can think about, I might have a data warehouse with tables, and as part of that, I want to query the tables in the data warehouse, but I also want to connect them up to some data that's in the data lake. Right. So if I can write a single SQL select statement that selects from both places and joins it together and maybe aggregates it, that's a federated query, right? if I wanted to hook up to another relational database also as part of that, maybe I bring in data out of my local tables, data out of a lake house or data lake, and data out of a a transactional database that's running MySQL, Postgres, or whatever, and bring all that together. Again, that's a federated query. So it's not just querying local data, but it's querying remote data in similar or other platforms.
Yep, and just really just being able to keep that in one block of code and have it run from one place. So
yeah.
So there's a building set of abilities on AWS to do a federated query. Walk me through a couple of the classic ones, and then some of the stuff. We'll kind of move towards some of the stuff that has been coming out as of late.
Yeah. So I'll kind of work through what I'd say is kind of traditional federation into some of the new things that Amazon is doing. So there are a number of database platforms who have some built-in federation capability within their platform. There are third-party tools that try to promote federation. That's out of scope for our conversation today. But when we look at AWS, the Postgres platform on AWS provides this thing called foreign data wrappers. That is a mechanism that allows you to represent data in other Postgres databases and execute federated queries amongst Postgres databases. And that's supported by AWS, both with RDS Postgres and with the Postgres compatible version of Aurora.
Yeah, so you can really you can work with that on-prem and everything like that, and really have kind of one experience to be able to query the data, which is definitely pretty cool, especially as you're going through kind of an evolution, or you have certain compliance issues, and being able to make that a lot easier. What about, you talk about pseudo federation a little bit as well, and some of that, I guess.
Yeah. So
what was a pseudo federation?
So there's kind of this native federation concept, and maybe pseudo federation is a really poor term, but when I think of federation, I think of I typically think, and maybe wrongly so, but I typically think of a fairly tight coupling between platforms, right? Platform A can query platform B because they've got some sort of standardized mechanism or relationship, right? So kind of swing into the other end of the scale from something like Postgres, which has a built-in, fairly rigorous mechanism for querying only other Postgres databases. On the other side, we've got Amazon Athena. And Amazon Athena has a few different mechanisms for federation, but the one that kind of strikes me the most in this particular question, pseudo federation, is Athena's federated query capability. Athena federated query, the way it actually works is they use these things called data source connectors. And data source connectors are really just AWS Lambda functions that adhere to a certain specification for an interface. And that allows Amazon Athena, through their federated query, to access other data. So in that space, just to dive a little bit deeper, Amazon has pre-built connectors running on Lambda for things like CloudWatch Logs, DynamoDB, DocumentDB, a number of RDS databases and JDBC compliant databases. And what it allows you to do is when you query with Athena, you can query against these things. And what actually happens is, as Athena is doing its distributed query, it's invoking these different lambdas as well. And the lambdas are actually connecting up to the data source, collecting the data per the query parameters, and then returning that set back to Athena, which then does whatever joins and aggregations and stuff with the other data that it needs. So you can write a single query in Athena that hits multiple databases, data platforms, and merges all that data again, like we were talking about before in federated query, into a single result set.
Yeah, and I know that there's there's some different operations that Athena's just come out with more recently as well. But what are some of the limitations maybe to some of the custom connectors or just connectors in general?
Yeah. So with the Amazon Athena connectors, they're really for read purposes. So write back is generally not supported. Athena standard views, these things can't be used in feeding the standard Athena views. And we're going to touch on that a little bit more in a minute. But outside of limitations, you kind of mentioned custom connectors. Amazon also provides a software development kit for Athena Query Federation. So you can write your own connectors. So if you're running a forgive me, all the people who are a mumps database, or some other system, or you've got your own API that fronts some data set. You can write your own Lambda using this software development kit, ensure it's compliant, and you could include that data in an Athena query as well.
Sorry, I have a classic. Every time I do this show, there's always some sort of work happening outside.
Yeah, it's just part of the realities of doing a show like this from home, right?
Absolutely. And within the federated zone, I guess, for lack of a better term, what I know Athena is obviously the first thing you think about, and I guess I'll let you go either way here. Either the other versions of Athena or the other things you can do with Athena, or maybe some of the other federated queried stuff that you can do maybe with Redshift or Redshift Spectrum, I guess technically is its own version of a federated query as well.
Yeah, so let's maybe since we're on the Athena topic, let's keep it stick on that topic for a minute. So we talked about Athena federated queries, which uses these Lambda based query connectors, which is extremely flexible, right? You can create all kinds of connectors, custom data access that you want, and write queries in Athena. What's interesting is Athena has released in preview so far a new capability called Elastic Views. So remember earlier I said one of the limitations of the federated query is that you can't make standard Athena views against a federated query connector. Well, Elastic Views takes you a little bit further with Athena, and it lets you create materialized views against multiple data sources, right? Now, this doesn't use, as far as I know, I could be wrong on this one, it doesn't appear to use the current connector structure. It looks like they might be using a different one. But some of the things that they're talking about, and remember, this is in preview right now, so it's kind of a beta software. People are playing with it. You can go sign up for the preview and try to get access. But one of the things it does is, because it's a materialized view, what it's really doing is taking the results of your query and copying them and storing them for further query purposes, right? So rather than a truly federated query where you hit the query and it's going to go hit all the other data sources, you're creating a view that's a federated view. But what it's doing behind the scenes is gathering that data, materializing it locally, so that when you hit that view over and over again, you're not constantly hitting those third-party systems. You're only hitting the local data. Now, what's interesting about this, and I have not had a chance to play with this yet, I'm not on the preview right now, but I'm watching what people are doing and saying about it, is these views supposedly continuously monitor for changes in the data to keep that materialized view up to date. So from a standpoint of, next week, we're going to be talking about ingestion, this is also an ingestion mechanism, not just a federated view mechanism. So if you think about the materialized view as a local data set, it's now ingested from those third-party systems. What I don't know is how, when they say continuously up to date, what does continuously mean?
Yeah, how often is that getting updated?
Yeah. Is that every 5 seconds? Is it every minute? Is it every 10 minutes? Is it immediate? As soon as it changes, they know about it. But As a preview tool, it's currently limited. Right now, I think they're only supporting DynamoDB as a source data set, but they're talking about MySQL and Postgres as items that are coming quickly, both Aurora and RDS versions of those. But what's interesting is while Athena primarily interacts with S3, you can definitely store the results of your Elastic View, the materialized results, in Amazon S3 and query those with Athena. But you can also use Amazon Redshift and their open source service, Open Search service, used to be Elasticsearch, as destinations. So your destination doesn't have to be S3.
Yeah, that adds a lot of interesting use cases and architectures of why you'd use that. So does it also is leveraging like AWS Glue Elastic Views? I guess where's the handoff between those two? And
yeah, and I maybe this may be kind of a misnomer on my part. It really is officially AWS Glue Elastic Views, but I tend to think of it from an Athena perspective.
Yeah.
But the official term is AWS Glue Elastic Views. It's just when I think about these types of things, Glue really doesn't have a query capability engine in it. This is really so when you think about writing SQL against that stuff, I tend to think Athena. But just for clarity, you're absolutely correct. This is really Glue Elastic Views, and you can target S3, Redshift, and Open Search service as destinations for the materialized data sets.
Well, AWS does that a lot too, because really you can be in SageMaker pipelines, but really under the hood you're doing Glue, and so the marketing starts to blend in with everything, especially with to your point, especially when you're thinking about SQL. I mean, that's Athena when you think about it in that way. So
and what's interesting is if I recall correctly, if you go to their website, you can find Elastic Views listed under Athena.
Yep. Oh yeah. And that's I always would think about how the fact that AWS Glue is Spark, but then sometimes you could use Spark Streaming or Kinesis. Sometimes you could use Spark SQL, or you could use Athena. It gets really it starts to get really daunting. I think that's only going to get worse as every individual thing can start to do so much more. So
right. Well, and I find it interesting, the Glue Elastic Views, if the timing on it is reasonably short and it's reasonably efficient, this is a really cool way of collecting data from transactional data stores running inside AWS and in close to real time updating your data lake and your data warehouses with it.
Yeah, I wonder how
minimal effort.
That'll have to be one of those pricing trade-off analysis we take a look at too.
Yeah. Do I do a Glue job? Do I do something else? But yeah, so kind of in the Athena Glue world, you've got the Athena federated query, you've got the Glue Elastic Views as an interesting items. And I think the other area of interest is Redshift.
Yep. More materialized views.
More materialized views, more other stuff. But an interesting note, I'm going to swing back to the early part of our conversation and talk about the Postgres stuff.
Yeah.
Something people forget about is that Redshift is Postgres compliant from a client perspective, which is interesting because when you're talking about the Postgres native federation, Redshift can actually be a target of that. So if you have a application that's running against a Postgres database and you want to pull some data from your data warehouse in Redshift in for use by your application, you've got a couple of options. One is you could go query Redshift directly. Two, you could use Postgres's federated query capability and query Redshift tables that way as part of a single query, or use it to do a update table, create table kind of thing within Postgres to maintain a subset of that Redshift data inside your Postgres database as well.
So really, you just, you could use the cost savings of or more purpose built for transactional or whatever it may be, but still get the power of Redshift under as well with a seamless experience then.
Yes, absolutely. Absolutely. So, kind of back to the whole, you know, modern data architecture concept of being able to access the data from wherever you need. The question of local versus remote is a question of optimization, right? And when you start looking at, bringing data in through various pipelines and starting to collapse the different silos of integration and ingestion, which we'll talk about next week, into a single pipeline of ingestion. And now the question becomes destinations, right? I can run that data to Postgres, but if what I really need is data that's been curated in certain ways, having that data available to my application, let that data run through the standard curations into Redshift, and then pull the results that you need across either dynamically or on a regular basis to store locally within Postgres.
Yeah, and then you also maybe to segue over to it too. On the other side, you have Redshift Spectrum as well, which can be bringing data in, putting it in one table, and then that table could then be redistributed out amongst other databases as well. What are some of the other big pieces of Redshift Spectrum, and what makes it so powerful?
So, when Redshift Spectrum was announced, it was announced as, oh, hey, now we have Athena, which runs on Presto, as a tool that you can use to query your data lake. And if you also want to query your data lake from within a Redshift data warehouse, you can use Redshift Spectrum to affect the same thing. Spectrum's a different technology than Athena. It queries the data lake tables slightly differently, but the effect is the same. You can query them. So the question comes out of that. All right, which do I use? Right.
Yeah.
What's interesting here, and this is kind of the subtext that you don't hear about, and what we've seen people using a lot, is that Athena is kind of a standalone tool. Yes, you can connect, certain, visualization software to it. You can do things like that, but we find customers using it more from an exploratory and sandboxing kind of thing, right? Data scientists, I want to curate a certain data set to train ML models. I want to pull a data set and do some really heavy investigation into it. They might use Athena for those things. But the 80% use that we've been seeing people leverage when accessing a data lake is actually through Redshift Spectrum. And the reason for that is multifold. So the first part is, if I'm using a data lake to store all my data for exploratory purposes, for long-term, high cost of query, low cost of storage kind of thing, right? And I'm using Redshift for all my kind of operationalized data, the stuff I'm hitting all the time. So I've got low cost of query, higher cost of storage, right? Because I'm running a cluster of Redshift nodes, but I don't pay on a per query basis. I just have to make sure I have enough resource there to handle the queries, right? What we're seeing is Redshift, a lot of people put data into Redshift for those purposes. For that operational data purposes. And then they use things internally like federated identity. I've got a user as a Windows user, they're logged in, I'm federating my Windows ID over, I'm able to take that Windows ID and pass that identity into Redshift so we know, hey, it's John who's trying to access this. I now use Redshift grants to control John's access to the tables inside Redshift. Redshift Spectrum allows you to expose data lake tables, as they refer to them as external tables, but they look just like to a Redshift user, they look like just more Redshift tables, right? And I can apply grants to them. I can, the same levels of access that I'm managing for my native tables, I can manage for those. But now John, who is going into Redshift to query stuff, has access not just to the stuff inside Redshift, but all the data in the data lake. So now we have a federated query. I can write a select statement that selects certain elements out of the data lake and joins to it things and tables in the data warehouse itself and get all of those results back. Not as easy with Athena.
Yeah, and
right?
just probably, and to your point, just the cost differences, and it's one thing to be looking around doing ad hoc and really kind of that deep exploratory analysis. It's another thing when you pretty much know most of your queries that you need to run every day. You need to know why you need to run them, etc. So
and it's one thing if you've got a person who's like a data scientist who this is their job.
Yep.
Your job is to go and play with the data, find the nuggets in that data, and help us turn those nuggets into business opportunities, right? But when you turn around and you say, I want to do self-service work and I want to give my marketing people and my finance people and my HR people and my sales people access to data, what you don't want to be saying is, well, for this data, go over here and connect up to the data warehouse. And for this data, you need to go over here and use a special JDBC connector to talk to Athena from QuickSight or Tableau or something like that. You don't want to give them all these different paths and have them try to figure that out and figure out this labyrinth, right? What you want to do is be able to go in and say, oh, here's your data.
Yep.
It's all in Redshift. Here's what we call the data lake data in Redshift. Here's what we call the data warehouse data in Redshift. It's all available for you to play with.
Yep. By the way, we could also publish a specific data set for you. Now you can play around with that data set instead of
Exactly. So there's adoption and ease of use reasons why, in my mind, Spectrum makes more sense than Athena for the majority of end users out there accessing data lake data. Specialists, special analysts, data scientists, all these things, Athena is a great tool for them. But for non-specialists, Spectrum creates a more cohesive solution.
Yep, absolutely. Right?
So go ahead.
Oh, sorry. I was going to say, we've talked about a lot of reasons to use a federated query. What about some of the places where you wouldn't want to use a federated query?
Yeah, sure. So when you think about federated queries, I want to make sure we circle back because there's one thing in Redshift that we didn't talk about, but let's put a pin in that one for now. So remember, federated queries potentially put load on other systems, right? So if you're doing a federated query from Athena and you're hitting a database that is your production transactional database for your high volume application, it's very possible that you could write a federated query that puts a fair amount of load on that database. And then if you open it up and just let people write all the federated queries they want, you could take that database to its knees performance wise, right? So that's always a caution that you need to be thinking about. And if you have a low use kind of scenario, but you need the most recent data, the data that represents the current state of the world, using a federated query there makes a lot of sense. Because now I'm going out to that database and I'm getting the truth as of right now in that other database. On the other hand, if you have a high volume use of that data, but you can live with a little bit of time delay, it doesn't have to be right now. It could be as of 5 or 10 or 30 minutes ago. You could think of a federated query as a simplified ETL tool. Right? I can write a select statement that hits one or more databases. I can join different tables from those systems together. I can aggregate that data if I want to. I can reshape that data in the SQL statement. And I can either do a create table as or an insert into or an update of a table, deep merge across using a staging table by just writing SQL and leveraging the federation capability. So I could have a piece of SQL that just updates my data warehouse data in Redshift, or my data in the data lake via, Athena, by just scheduling these queries to run on a regular basis.
Another interesting trade-off between ease of use, maybe compute costs, and how that might differ just on the type of workload that you're initiating as well.
Yep.
And if it's already in AWS, to your point last week, and what we'll talk about next week with ingestion, is if it's in there, then you still have like the data lineage, and you can still track it at least all as you're doing the query, just like you said, with a kind of a light ETL and just doing it in motion. So,
and we've talked about the concept of SQL as your primary mechanism for doing ETL or ELT. And, these things, the concept of federation, some of the things we talked about last week, all work towards enabling people to do it with more simplified tools. And it doesn't always have to be graphical tools, right? If somebody who has taken the time to learn SQL, you can do an amazing amount of stuff with SQL.
Yeah, I think, I've always wondered if we're going to start rising, or just, this is a little off topic, but just between languages is, we obviously see Python taking off. SQL, it's kind of an interesting language, I guess you could say, but I think there's going to be maybe one other one. Maybe it's something like a Go or something that's really short with, or light on memory. But I feel like there all these other languages are going to start to kind of still dissipate, and you kind of Python, SQL, and then maybe there's one other memory language that comes up. That's kind of my thoughts.
And with regard to data processing, SQL and Python kind of rule the roost.
Yep.
And even in looking at, R, for example, there has been a decline in the use of R and an increase in the use of Python. And it's not because Python's a better language for it.
Mm-hmm.
It's all about support. Python runs on Spark. Python's got a rich set of ML tools. Python's got, it just, there's this support of Python in the ecosystem that just makes it kind of a no-brainer to say, okay, if I'm going to go learn R or Python, which should I learn? Well, Python's going to give me a broader reach.
Yep.
Right?
And now Python could run in web browsers, so that's just well,
that's a whole nother conversation.
Yeah, right?
Yeah, absolutely.
But you wanted to also circle back on some of the other stuff on Redshift.
Yeah. So I think, we talked about Redshift Spectrum. What we didn't talk about was Redshift Federated Query.
Yeah.
So Redshift also now has a federated query capability beyond just Redshift Spectrum, right? So Redshift Spectrum allows you to federate your query into your S3 buckets data lake, tables represented in Glue as your Glue schemas. But you can now also directly communicate to other databases. And it works in a similar way in that you create external schemas that represent the table structures in the other databases from a Redshift point of view. And for the end user, it looks just like the Redshift Spectrum tables. It looks like another table. And you can manage access to it with grants and things like that. They support right now, I believe it is MySQL and Postgres, both RDS and Aurora compatible versions. And, Redshift, when you execute the query, it will take portions to the query and push as much load to the other databases as it can to make your queries faster. But, like we were talked about before, all the load you push to those other databases is load on those databases, right? So if those are reporting and analytical databases, yes, that's probably fine. If they're transactional databases supporting a customer application, then you have to be a little more careful, right? So exposing that stuff can be painful. Now, Redshift does support materialized views. So creating a materialized view that updates on a regular basis. And I'm going a little far afield because I haven't verified whether Redshift materialized views work well with Redshift federated query or not. But if it does, that's a great tool to use, because then you can create a local table within Redshift that represents the results of that query. And you can balance how often you hit those remote data sources to update your data. So you can find the right balance. How fast do you need that data in Redshift is the question then.
Yeah, and I was just looking through some of the limitations. So it looks like you can't right now. You can't alter a schema, but you'll just have to drop or just create a new one. But I don't think that should be too
That's
hard.
typically not something that happens on a regular basis, right?
Yeah. Just control C and control V. I think you'll be able to be all right and just start a new one from there.
Well, and the other aspect is if you're doing your Redshift stuff right, you are automating all of that. It's all scripted, right?
Yeah.
So, recreating a schema is really just a matter of modifying a script and running the script again.
Yep. And then, you can just have it automatically drop and just create a new one. But I think it provides a lot of interesting architecture considerations, and not even just architecture. Maybe it's even more granular than that, of just the workloads and where you're going to run those. And, I think you brought up something too that we always forget about is the actual administration of it all, and how are you administering it, both from a user standpoint and how the resources are talking to together. Because obviously a federated query, you have multiple resources speaking to each other. So
well, and think about the past and where we've come from. So if you think about what we used to have to do, if I wanted to get that data out of that transactional system into my data warehouse, I had to do some sort of extract, transform, and load, right?
With a very expensive tool, by the way, as well.
Or hand coding.
Yeah.
Right. Even in the AWS world, hey, I'm running Aurora Postgres. I want to get data from Aurora Postgres into Redshift. Well, I have to somehow get the data first out of Aurora Postgres. So that might be a SQL statement or a dump of some sort to S3 of that data. And then I have to load it into Redshift, but I have to create a table in Redshift that either exactly replicates that structure, so I can do a simple Redshift copy command, or I have to manipulate that data first using Glue or something like that, right? Or using a script. Glue comes along, I can connect to an RDS database, grab the data, manipulate it, connect to Redshift, and store it in Redshift, or more specifically, write it to S3, and then connect to Redshift and issue a copy command, right? But it's all very manual. Or you're looking at, the classic, old school tools like Informatica, or some of the new school tools like Matillion, to do that same thing, and you're paying the price for that.
Oh yeah,
right.
Either paying with a very expensive tool that's a human, or you're a very expensive one like Informatica or Matillion too.
But now you can go at it and say, well, I'm automating my infrastructure in AWS. So as part of that, I will automate my connectivity between my Redshift cluster and my Postgres database. I will set up authentication capability inside using Secrets Manager, so Redshift can properly authenticate to that. And now that I've got that done, all the tables that are accessible to that identity are now available to Redshift. And I can go and I can create that external schema that represents it. I can query it. I can create materialized views, or just run my own manual queries to generate tables inside Redshift. Suddenly it's much easier. Oh, I need another piece of data. I don't have to go through the whole export, manipulate, load process. I just write another SQL statement, another select statement. I create another materialized view, and boom, it's done.
Yeah. We went through event-driven systems. I mean, this is kind of like, if it's always updating, it's kind of like an event-driven system in its own right too.
Yep.
And I guess that's an interesting question, and not to get off topic at all, but maybe how would working with materialized views versus maybe setting up a process with EventBridge, or maybe it's step functions, or maybe there's certain workflows that you wanted to do, or maybe there's some trade-offs there. Or...
Well, there are, this is again, when we start about when we move from federated query to just the more broader concept of how do we move data from one source to another, it opens up a whole lot of worlds. So, for example, let's take you have a database platform that you've got, or you've got an application that you've built. It runs against Postgres, RDS Postgres, or Aurora Postgres. And you want to get that data into Redshift as close to real time as possible. Right? So one answer is, well, let's do Redshift federated query, and we will just query that database every time we issue a query. Right? So I will always get what is current in that database. All right. So let's walk that road. That works functionally, technically, but performance-wise, if I have a lot of users hitting that query, I'm adding a lot of load to that Postgres database. Now, I might be able to absorb that load by using read replicas and that kind of thing. Definitely an option. That's definitely more cost.
Yes, exactly.
But you have other options as well. So, for example, let's assume that you are using data access objects to write to the database. Your data access objects could write change records to EventBridge. EventBridge, you could have a rule that picks up those change records, runs a transform on them, and pushes them into Kinesis Firehose. Kinesis Firehose now supports near real-time streaming into Redshift tables.
Without going into the S3, without going in the old S3 bucket.
Yep. Doesn't have to go to S3 anymore, anything like that. So now you've created a scenario where not only are writing to your database, but you're emitting a change event that can go around. You got to do a little more coding. You got to do a little more work, but you now have a real-time flow of change into your data warehouse. If you're backing your solution with DynamoDB, which right now Amazon Redshift does not have a federated query capability for DynamoDB. Athena does. You've got an option of using DynamoDB streams to produce those change records. So now you're not having to write code to do it. You're just configuring the DynamoDB streams to output those records. And again, you can connect those streams up to Firehose and have Firehose write. Or after it comes out of preview, you could take Glue Elastic Views and you could create a view that it queries that data in DynamoDB and writes the result of that view in real time to a table in Redshift.
Yeah, it's getting crazy, really, is what it is. And I think what's going to maybe drive it too is, it's one thing to go in greenfield and build it. It's another when you have maybe groups at a large organization with certain sets of talent, or maybe they just want to use certain types of technologies too. I feel like that might start to, if there's not really good top down from AWS to really, push these best practices, I mean, you could start to see a billion different things. So
and that's one of both the strengths and weaknesses of AWS is they design for builders. They don't they're not highly opinionated on how to do it. They provide you options, many different tools to use, and they might provide some best practices. But like we were talking, last week, as things get closer and closer to non-technical users, think QuickSight users, right? You need to be more and more opinionated because they prefer to be shown a way to do it that works really well for them, as opposed to saying, well, there's a dozen different ways you can make this happen. Choose what's best. Right?
You tell us.
Yeah, exactly.
Let the community fail fast instead of the internal AWS teams too.
Yes, absolutely. So I was going to go peek. I don't know how many people are watching us live at the moment, but no chat, no questions on chat. If anybody is watching live and they have questions, you can always on YouTube or LinkedIn Live, add your questions to the chat, and we'll see them and take a shot at answering them for you.
Yeah, and also might be a good time too for people that are watching. We are looking for guests, so I know that we have a really good guest coming up. I'm not going to surprise who it is yet, but I know that we got some good ones coming on. But if you are interested in coming on and kind of going back and forth with Michael and I on random topics within AWS, and feel free to reach out because we'd be happy to have you on as well.
Excellent. So, John, any other questions on Federation?
I think I could probably go down this rabbit hole of when to use Federation or not within like certain types of eventing and stuff like that. But I guess, that could go into a lot deeper rabbit holes just on pricing offsets that we haven't accumulated the data for yet. So.
Yeah. Well, why don't we capture that as another show topic? Because I think we could spend an entire show just talking about, if I want to get data from point A to point B, and what are the different ways under different use cases? Why would I pick one way over another?
Yeah, no, because you got to think a query is it's kind of ETL in its own way technically. So, kind of where the lines are getting blurred, and also, you brought up Kinesis, and there's a lot of things you can do in flight with Kinesis. There's a lot of things that you could do at the destination. How does that? Because you got to think there's the human element and the cost of coding and the cost of upkeep and
cost of maintenance and monitoring and observation.
I think that'd be I think that'd be a valuable exercise for the community in general too. Of just maybe there's like a associate, a senior, and principal level. How long does it take them to do certain types of things? So I think that'd be a cool calculator to start building. I know you're an Excel wizard, so I think that'll be I think we'll have a massive calculator maybe by the end of it. So
I just need to get a whole bunch of apprentices that I can teach to do it.
Yeah, right. I can do all right with Excel, but it's been a while since I learned it pretty heavily in school. Actually, that was like one of my first in Providence, my FIS, Foundations in Technology, or FIT, Foundations in Technology, and we went pretty deep in Excel. So I got good at one point, but my skills have faded over the years. So I'll have to get back in and start working on those calculators. I know you've sent me a few over the years. So
awesome.
Well,
I think it's probably appropriate for us to start wrapping up here then for today. So as always, I want to say thank you to everybody who has joined us live and everybody who's watching us after the fact. We thank you very much for joining us. We hope that you've learned something today. Add another arrow to your quiver. If you liked what you heard, please subscribe, follow us on LinkedIn, subscribe to the YouTube channel, and then join us next week for some more wonderful information. I think we're going to be talking about ingesting data from external outside of AWS sources. It'll be at the same time, 11:30 Central, and we will see you then.
Happy Juneteenth, everyone.